Welcome to Quantum Photonics. We are here to listen to our speaker discuss his new study, which can improve attention and executive function, cognition, as well as physical endurance and resistance exercise performance. BET is a combined exercise and cognitive training method that was originally developed to increase endurance among elite athletes. The research has implications for healthy aging, and previous studies have shown that mental fatigue can impair both cognitive and physical performance, including poorer balance control, leading to increased risk of falls and accidents. This study, published under the Psychology of Sport and Exercise, is the first to examine the benefits of BET for both cognitive and physical performance in older adults. So we have here our guest speaker to talk about this paper, Professor Christopher Ring, who is Christopher Ring was PhD in psychology in 1993 at the State University of New York at Stony Brook, USA, and he is a professor of psychology at the University of Birmingham in UK with 200 plus journal articles, a Google Scholar, H index of 75, and 15,000 citations with many papers on cognitive and exercise performance. To address this problem of mental fatigue impairing performance, he pioneered brain endurance training, BET. These protocols and demonstrated BET's effectiveness as a performance enhancer. He helped Mr. Grant Hayes, CEO of Soma Technologies, to develop the Soma NPT app and Soma analytics software for implementing cognitive testing and training, such as BET. He has extensive experience training highly qualified personnel, including junior staff and postdoctoral researchers, and is an excellent mentor who provides outstanding environments for young academics to realize their potential. He mentored 10 plus postdoctoral researchers and supervised 30 plus PhD students to completion. Most have gone to successful academic careers. He possesses a global network of academic collaborators and industry contacts. He has contributed to the global reputation of his school as a center of research for excellence, scoring highly both nationally and globally. He has ongoing collaborations concerning BET interventions with academics in the UK and abroad, underscoring the global reach of his research. He is regularly invited to give talks, media interviews, review grants, review journal submissions, and examine doctoral dissertations nationally and internationally. Since the COVID 19 lockdown in 2020, he has worked closely with Mr. Grant to foster BET studies and develop and promote Soma NPT app as a research and training tool. So you will see the link there at the room chat. He regularly undertakes public engagement and outreach activities, including workshops, talks, interviews, websites, and social media postings to highlight the role of fatigue on performance and the benefits of BET as a countermeasure against mental fatigue. He has so many publications. I will just post it here at the room chat for you to check later. So we are very privileged to have Professor Christopher Ring with us here now in Quantum Photonics. Welcome, Christopher.
Thank you very much, Cecile, and members of the Quantum Photonics Brotherhood, Sisterhood. It's a pleasure to be here. What I'm going to do today is I've prepared some slides to introduce the general principles before we get into looking at the specific study that you highlighted just now on the use of BET in older adults. So what I've done with the slides is I've numbered them, and so when I get to each slide, as long as my memory is still with me, I will announce the slide number, and then I'll talk to that slide. So my My opening slide, slide number 1, just gives you a little bit of an overview of what I'm going to talk about. Benefits of combined cognitive and physical training, i.e. BET, for performance. And as Cecilia noted in my introduction, I'm Professor of Psychology at the University of Birmingham. So if we go to slide number 2, the psychobiology of exercise. So here is a very influential man, younger man than me at least, Professor Samuele Marcora, who's now at the University of Bologna in Italy. And Sam is a exercise physiologist by training, and what he revolutionized the field of exercise physiology by challenging the standard view that exercise is limited purely by physiological factors. And what Sam was able to show and argue in a series of sort of seminal studies was that what stops people in the context of endurance exercise is not neuromuscular fatigue, but rather a psychological phenomenon, i.e. perception of effort. So people go along exercising or doing a task, the amount or the extent to which the ongoing task imposes demands and ongoing effort on the person continues, and then eventually the person decides to stop because it meets some sort of threshold for effort. And broadly speaking, in this model, which has been very widely used to sort of frame the next sort of 10 years of work in this field, the key determinant of exercise performance is effort. And along the way, what Samuel was able to show was that if people are in a state of mental fatigue, that mental fatigue causes increases to perceived effort during the task, and as a consequence, people will stop exercising sooner than they would do otherwise. So what do we mean by mental fatigue? So if you just look at slide 3, well, mental fatigue has been defined in many different ways. There's no agreed way to define it. So I'll give you here this rather general definition of mental fatigue as a state of tiredness and diminished functioning. That could be cognitive functioning. It's a normal transient response to exercise and to exertion. So, for example, the way it's operationally studied in the laboratory is experimenters will ask participants to complete relatively long, hard cognitive tasks. And as I said, the important distinction here is we're not talking about neuromuscular fatigue, where there's some failure to produce a certain amount of work. This is a different phenomenon. So if we turn to slide number 4, on the top left there's a little schematic showing that mental fatigue is associated with reductions in cognitive task performance. And this is a sort of a parallel literature really to the one that I've mostly been concerned with. But this is mainly within the field of psychology, but also work within human factors. And what they show quite reliably is you create a state of mental fatigue, either by performing a cognitive task for a very long time, or by imposing additional cognitive demands, and that leads to deteriorations in cognitive performance. So the classic forms of cognitive performance: executive functions, attention, reaction times, etc. In the bottom left of this slide, it's the research that has accumulated from exercise physiology showing that states of mental fatigue can also reduce exercise performance. On the right of this slide, there is a figure from a study by Sam and colleagues from 2009. And what it shows is, it shows here a time to exhaustion on a bike test, and it shows the ratings of perceived exertion, or the amount of effort that people are feeling while they're cycling. And what you'll notice from the uh, well, in about minutes 0 to up to about minute 6, the amount of perceived exertion gradually increases. So as you keep going on the exercise task, it's perceived as being increasingly hard. Interestingly, here there's a manipulation, and that manipulation is the participants perform this exercise test on 2 separate occasions. Under normal standard rested conditions, or the control shown in the open circles, and then on a mental fatigue manipulation day shown by the closed or filled circles. And this mental fatigue was created by having participants complete a very long and demanding, maybe boring task for, I think this was 90 minutes before they started the exercise task. And what you notice there is that right from the very get-go, the under the mental fatigue conditions, people are finding it harder. They're giving higher ratings, and that just carries on. And then, if you look to the right of the slide, there's 2 little singular circle dots at the top underneath the time to exhaustion. You'll see that under the mental fatigue condition, the participants stop after about 10 and a half, 11 minutes, whereas under the control condition, they stop after about 12 and a half, 13 minutes. So there's a substantial and significant reduction in time to exhaustion when the participants have completed a prior long and demanding cognitive task. And this research has spawned a massive number of publications in the ensuing years. I haven't looked recently, but it's a very high and increasingly cited paper, and it's a field that has explored the effects of mental fatigue in a whole variety of exercise contexts. So if we turn to page 5, we can ask ourselves, do we have a problem here? I think the answer is definitely yes. As I said, there's an abundance of evidence showing that if you put somebody into a state of increased mental fatigue, performance generally deteriorates. It doesn't deteriorate in every single occasion, but more often than not, performance is impaired. Now, as well as adding and expanding this literature to extend to different sorts of outcome tasks, different sorts of exercise, different populations. What I've been most interested in is saying, okay, we have a problem, let's do something about it. And this view has been increasingly shared by a number of researchers in this area. And as a consequence of this interest, people have developed and evaluated what I would call short-term countermeasures against the deleterious effects of mental fatigue on performance. And these countermeasures, the most commonly used one is one that many of us use ourselves every day, and that is to have a cup of coffee. So caffeine is a good countermeasure. The problems with caffeine is we tend to habituate to that, and it doesn't. We have to keep increasing the dose to have any beneficial effects. And if you're an athlete and you're taking a lot of caffeine, you might have trouble sleeping, and sleep loss itself is a cause of mental fatigue. And then there are some more psychological short-term countermeasures. Motivational self-talk is quite a popular one, and then various forms of provision of feedback. But we've taken me and collaborators who I work with around the world, we've taken a different tack, and our tack is, rather than short term, we've developed some interventions based around brain endurance training, BET, as a long-term countermeasure. So what I'll do is I'll explain that a little bit to you over the next few slides. So if we go to number 6, so here these are two influential figures. There's Samuel Makora again, and then underneath that is Dr. Walter Staiano, who was a postdoc, ran the first brain endurance training study with Samuel and continues to sort of pioneer some work in this area. So let's move now to number 7. So what's the rationale behind brain endurance training? If we look here on the left side of the slide, what happens during brain endurance training? Well, during brain training, what you do is you add cognitive tasks to a standard physical training protocol. And you can add those tasks before or during, or sometimes even after the physical training. But the idea is that if you complete these cognitive tasks either during or before the physical training, what that does supposedly is it increases the cognitive demands, and then it will then cause some adaptations. Those adaptations have yet to be specified or clarified from research, but this is the assumption. And essentially what that does is it makes training harder. So for exercising at the same absolute workload during brain endurance training, the participant will actually find it harder. And what this does is it recalibrates the relationship between the actual demands of the task, the workload, for example, and the perceived demands of the task, the perceived effort required to, let's say, cycle on a bike at 200 watts. So you do that, you do brain endurance training for a number of weeks, training several times a week if you can. And then after the end of the training protocol, weeks or months later, what you expect to happen, and this is in line with Sam Makora's psychobiological model, is that it will reduce the perception of effort. And what that means is that for the same amount of physical workload, let's say 200 watts, you will now perceive that to be easier. And because you perceive the exercise demands to be easier, you're able to carry on for longer. And therefore, exercise performance, particularly endurance exercise performance, where this was first targeted at, is expected to improve. Okay, now for on slide 8, there is the first true brain endurance training study. This was presented by Sam Makora and Walter Staiano at a conference in 2014, again in 2015. And what this very first study was a 12-week brain endurance training. The classic design of these studies is you randomly allocate half the participants to a standard exercise protocol or control condition, and half the participants to a brain endurance training condition where you add cognitive load to the standard physical load. So the important thing here is that the physical demands of training are the same across the BET and the control physical training group. And what we can see here from the middle figure, time to exhaustion as a function of different phases of this experiment: pre-test, mid-test, and post-test. So this was a 12-week intervention. So the mid-test happened after 6 weeks, and the post-test happened after 12 weeks. And what you'll notice is that the control group improve. I mean, when you do physical training for 12 weeks, your performance gets better, so they improve their time to exhaustion. But most importantly, the brain endurance training group increased substantially more than the control or physical training group shown in the red. So this is a study that was, I suppose, revolutionary, really. It caught a lot of interest. And if you turn the page onto number 9, this is an example of the impact beyond academia that this first study by Marcora and colleagues had. And it was picked up by this fellow here, Alex Hutchinson. He's a media journalist, writes a blog on sweat science. He's a keen runner himself and interested in this area. He's written this very good book. I recommend to you, Endure. You can find that and give it a read. And what Alex did was he had many conversations with Sam and thought he'd try it himself. He tried it himself. He didn't particularly like it because, as I said, brain endurance training the makes the normal training actually harder, and so Alex obviously struggled with this, and I'm not sure if he wanted to continue with it. So this was in 2015-16 time. If we turn the page onto slide number 10, I've highlighted some of the studies that have happened since. So in 2014, it was first presented at a conference, this first Marcora study, looking at cycling time to exhaustion. And then there was a hiatus. And quite why there was a hiatus, I don't really know. But we at the University of Birmingham, me and my student, PhD student, Neil Dalloway, and Dr. Sam Lucas, co-supervisor of Neil, we thought we would set about trying to replicate this initial finding, and we were able to do so. We published some of those from those data in 2021, 22. There's been a replication of the original Marcora study by Baza Kapoor. It's unfortunately it's in a foreign language, but you can kind of make sense of it. But it's a pretty much a close replication. And then Walter Staiano has done some studies in professional athletes, professional footballers, and very high level cyclists. Again, generally confirming, not in every single exercise test, but in most of the tests, that if you engage in this brain endurance training for between 4 to 8 weeks, typically, then there's an improvement in exercise performance. And then just very briefly, if we turn to slide 11, I'll go through these very quickly. This is some data from our first study with Neil Dalloway et al. 2021. We looked at hand grip endurance. People were asked to produce force using rhythmic hand grip contractions. And what we show essentially here is that after 6 weeks of brain endurance training, 4 times a week, 30 minutes per session, there is an improvement in exercise, in this case here, force production with hand grip. If we could turn to number 12, we replicated this and did it slightly differently and published a study in 2023, again showing that I think this was 5 weeks of brain endurance training improved hand grip performance. Slide number 13, this was now a study, is a dual study actually, with Walter Staiano and Sam and myself and some others. And what we showed in these two studies was time to exhaustion, similar to the original Marcora study, and then also a 20-minute time trial was improved by brain endurance training. And then the final study I'll just highlight was that this was now a slide 14, again headed by Walter Staiano, involving Sam, myself, and some other people. And this was looking at professional football players, and showed that in a pre-season bet training environment, the footballers improved their running performance relative to a standard exercise-only training group. We do have some other studies, but I don't have time to mention them to you today. So on slide 15, I've just sort of summarized what's going on here. So you train, you physically gain. And that's what we find for nearly all of the studies. I think there's about a dozen or so studies now published on this, mostly in the last few years. And what they do is they confirm that if you engage in brain endurance training, then you can improve exercise performance. And a variety of exercises you can improve. Mostly the early work was on endurance exercise. So we looked at things like cycling, running, and then the hand grip. But the latest work that we have done has extended it to resistance and strength endurance type exercises as well. Now, along the way, and in fact, rather accidentally, we sometimes included in our tests, along with the physical tests or the exercise tests, we also sometimes included some cognitive tasks. And in three studies, we found that the brain endurance training group were not only improving their exercise performance compared to standard physical training group, but also we saw that they were improving their cognitive performance. And so this started us to think that, oh, if we're able to improve both cognitive performance along with physical performance, maybe we should look at this a little bit more systematically. So over the last few years, our studies have now, rather than accidentally measuring cognition, have actually more formally measured cognition. And then, and this is the reason for me speaking with you today, we thought that we would try and extend this work on BET to other groups, other types of tasks. And so we set about, and the study was initiated a couple of years ago now, looking to see whether the benefits of this form of combined cognitive plus exercise training could benefit older adults. And the rationale for that is very obvious. Older adults have deteriorations, age-related deteriorations in both cognitive and physical performance on average, and there are many consequences of those reductions in their abilities. So we thought we would see whether we could extend BET into the world of older adults. So on slide 16, that's the study that just got published that Cecilia contacted me about and wanted me to talk about. This study came about. This is a collaboration, mainly driven, I must say, by my colleagues at the University of Extremadura in Spain, and the professor there is Professor Tomas Garcia Calvo, and my close researcher is Dr. Jesus Diaz Garcia. And this study came about really by accident. And it came about because Jesus is a paddle tennis coach, and along the way, he as well as his academic job, he also manages to coach. And he happened to be coaching a group one day, and one of the members of the group, this lady, started talking to him. And it turns out, and said, "Oh, what do you do for your day job?" And Jesus explained what he was up to, because Jesus and I have been collaborating on a number of other BET projects. And he said, "Well, this is what I do. I look at the effects of combined training and mental fatigue on performance." And this lady happened to be the mayor of their village. The village is Torre de Miguel Sesmero, and you can see a picture of the torre, or the tower, in the picture on the left. And so what we did was set up a protocol and adapted a protocol for use with older adults. This study was concentrated on older female adults aged 65 and above. So if you turn to slide number 17, This gives an overview of the protocol. It's a rather complicated slide. It tries to be graphical. But essentially what happens is we have a small number of women, and that is a limitation of the study for sure, and we randomly assign them to one of three groups. They go into a brain endurance training group, they go into a physical training only group, and they go into a passive, neither cognitive nor physical training control group. And what happens is they get tested 4 times. There's a pre-test at week 0, there's a mid-test at week 8, there's a post-bet test at week. There's a mid-test at week 4, there's a post-training test at week 8, and then between week 8 and week 12, there's no training at all, and then we have a follow-up to see whether we get retention after 4 weeks later at week 12. So what happens between weeks 1 and week 8 in the two groups? So the physical training group, they're asked 3 times a week to perform some resistance training exercises and do some walking activities. And they're pretty low intensity. They're not particularly onerous, but they're manageable for this particular population. And then over and above that, the women who were assigned to the brain endurance training group, before they did their resistance and walking exercise, they were asked to perform a 20-minute cognitive task. And so this is what we would call a prior bet or pre-bet training protocol. The idea is that the 20 minutes of cognitive task before starting the resistance and walking tasks is meant to increase mental fatigue and make the exercise training harder. And if Marcora's model is correct, that should change people's perception of effort, recalibrate the relationship between perceived effort and actual effort, actual work, physical work. And then after having completed that, in this case here for 8 weeks, that they would be able to find the exercises easier, and they would be able to perform the endurance for longer. So as well as we've learned our lesson, and as well as looking at exercise only tasks, we also added in a couple of cognitive tasks. And the cognitive tasks that we added in this classic Stroop task, Stroop color word interference task, which essentially tests your ability to ignore or to inhibit your natural response when you're presented with words written in particular colors to actually read the word, and instead you just have to name the color. That task, we use one implementation for the testing. I should also say we also use that same task for the training in a slightly different version of it. So there's a little bit of overlap between the training cognitive task and the probe test cognitive task. But in addition to doing the Stroop task at each of the testings, we also asked participants to complete something called the psychomotor vigilance task. And essentially what that's doing is it's like a reaction time task. A stimulus appears on a screen and you're asked to press the screen, react as fast as you can. And your reaction time, the speed at which you're able to respond, is thought to reflect or capture your readiness to respond. Now, as well as those two cognitive probe tasks that we did, we also assess physical performance using some fairly standardized tests. In this literature of exercise and older adult performance, there's a battery of standardized tests, and we chose 3 tasks from that battery. We chose the chair stand test, where you start off sitting in a chair, you have to stand up, and then you sit down again and stand up. And you do that exercise, that as many repetitions as you can over 30 seconds. We also looked at something called the arm curl test. So you sit in the chair, you hold a weight in your arm, at 1 kilo weight we used here for these older ladies, and we're asking them to do a bicep curl and repeat that as many times as possible in 30 seconds. And then the final test we did was we asked the participants to walk over the duration of 6 minutes and to walk as far as they could. So we have a way here of assessing, I suppose, the arm curl and the chair stand are looking at sort of strength endurance, and then the 6 minute walk test is looking at aerobic endurance in the participants. So the next series of slides are really presenting the data for each of the tests. The first three are for exercise, and the second two are for the cognitive. So on slide 18, these are the data from the 6 minute walk test. All of the data are presented in the same general format. You'll see there's a written in red, there's a 30-minute stroop, and then some like these dots going down the screen. So the test was performed on every test session. It was performed twice. It was performed when they were in a relatively rested state, non-fatigue state, and then it was performed after they had completed a 30-minute stroop task, which is the most commonly used task to induce mental fatigue in this literature. So we're testing people essentially fresh on the left-hand slide and then fatigued on the right-hand side. They're fatigued not only by the 30-minute stroop, of course, but the fact that they've already done the series of exercise and cognitive tasks during the testing. So if we start out here, and the pattern of the data are broadly similar, what we find is that the compared to the control group, who really don't show much changes, the control group, this is the participants who didn't actually do any exercise, didn't do any cognitive training at all. Their performance, for example, here in the 6 minute walk test is pretty stable across the course of 12 weeks. Whereas the two intervention groups, BET and exercise only, the purple, what are they? They're sort of diamonds. I don't know what that shape is. Anyway, the purple data for the BET group and the exercise, the green circles, they show improvements gradually after 4 weeks, performance starting to improve, and then after 8 weeks, performance reaches its best. And that happens for both before the 30-minute stroop and then the second time they're tested after the 30-minute stroop, and they're relatively more fatigued. After the 8 weeks, as I mentioned to you, formal training stops, and we retest people 4 weeks later at week 12 to see if there's any retention. And what we find is that, again, in both of the two exercise only and exercise plus cognition, i.e. the BET groups, we have a little bit of a drop off in performance, but it's still, the performance tends to be a little bit better than the control group. If we turn over to slide number 19, this is now the chair stand test I described. What you'll see there on the left-hand figure is performance is improving from week 0 to week 8. There's not much difference across the three groups, it should be said. But when we test again after the fatiguing 30-minute stroop, or they've been fatigued by doing the exercises as well, we get clear differentiation, clear benefits of both the BET group and the exercise group, shown by the purple and the green, compared to the control no intervention group. And then on slide 20, our final physical test, the arm curl test, looking at arm strength, we find a very similar pattern. Performance improvements with physical exercise and with physical plus cognitive exercise. The benefits are seen more clearly here, both before the 30-minute Stroop and after the 30-minute Stroop, with a drop-off between weeks 8 and 12 when there's no training happening. And then if we look at slide 21 and then 22, these are showing us some similar patterns now for the cognitive performance. So this is the slide 21 is the performance of the Stroop color word task. And what you'll see there on the far left is an example. So people would see words written in incongruent colors. So the first one is red, the word red, but it's in green ink. And what you're asked to do is to ignore the word and say the color. So you would say green, yellow, red, black, red, green, ignoring the words. And so we've learned language over the years, and so our natural response is to read out the word. So you have to inhibit your natural tendency to read the word. And that's one of what's called, it's one of the so-called executive cognitive functions. These are core functions that are that we as humans use for planning and doing the majority of tasks that we require to do. So this Stroop color word task, which is trying to capture this process of inhibition or response inhibition, when we look at the data for both before the 30-minute Stroop and after, so when fresh and when fatigued, we see that there's improvements in the number of words that they're able to correctly articulate, both for the BET and for exercise, and very clearly here, the BET group has an advantage over both of the groups. And then the final data slide is from the number 22, is from the psychomotor vigilance task. Before the 30-minute Stroop, there are some benefits for the two exercise and BET groups compared to control. And then after the 30-minute Stroop, it becomes even more obvious that the BET group shows an improvement in the reaction times during this task. So on the right hand panel, we see that the purple lines are lower than the green lines. So that are the data. The important thing is that the benefits of BET aren't shown for every test and for every occasion, but broadly speaking, BET is enhancing performance, definitely relative to control, and on more occasions than not, it's also improving performance relative to the exercise task. One of the problems with this particular study is that it was a relatively small study. There were only 8 participants per group, and so therefore we clearly need to replicate this study and recruit larger numbers of participants to test the protocols. One of the other issues with the study is that the training cognitive task, the 30-minute Stroop, overlapped with one of the test tasks, i.e. the brief Stroop. So ideally what you'd want to do with training is to have a different training load compared to the testing task. But that's something that we plan to correct in our upcoming studies. So now if we turn to slide number 23, we're getting to the end. I know it's an endurance study, an endurance talk, so I thought I'd take you through the ringer here. So slide number 23, this now is a chance for us to start to reflect, and this is where it starts becoming interesting. So if we look at this evidence, some of which I've presented to you today, but some of which is available from my other studies that you can read, we find that BET improves both physical or exercise performance, and it improves, we're starting to show that it improves also cognitive performance in both young adult athletes, where most of our work has happened so far, and then in this very latest study looking at older sedentary adults. So the evidence base is growing. It's not massive. As I said, there's about a dozen or so studies, but we're confident that we've got something and that we can maybe build upon it. So what's going on here? Well, Professor Sam Marcora, his psychobiological model argues that what happens with BET is you have this recalibration of the perceived effort to actual work, actual effort relationship. And I didn't present the data to you here, but in a number of studies, we do confirm that and show that ratings of perceived effort are actually attenuated following brain endurance training. In terms of physiological mechanisms, researchers have looked at a number of physiological responses, cardiovascular and muscular activity during these tasks, and have generally not found any differences between BET and the standard physical training groups. In the two Dalloway studies, the Dalloway 2021 and the Dalloway 2023, people asked us, why are you looking at endurance with hand grip? Well, one of the reasons for that is because it's possible then to start looking at some physiological responses. And so in those two studies, we used something called near infrared spectroscopy and put probes on the scalp to look at brain blood flow and extraction of oxygen during the physical tasks. And in both of the studies, what we showed was that from pre-BET training to post-BET training, there was an improvement in the efficiency with which the participants performed the task. And that was not seen in the standard physical training group. So we have a hint that there are changes in prefrontal activity, some adaptations that are happening. Ideally, we're going to extend that and start to look at it in using techniques like brain imaging, functional magnetic resonance imaging. But that's for the future. These BET studies are difficult to run. They're training studies. There's lots of sessions. There's lots involved. So to add on top of that, to do fMRI and EEG and what like, it really does make for really rather complicated studies. But that's what we would like to do, and that's what we're planning to do in the relatively near future. And then finally, on slide number 24, this is just me sort of thinking about where we are and where we're not, and the difference between those and what gaps we need to fill. The obvious first thing that we want to know is what training dose do we need? We've typically had training for between 4 and 12 weeks in these studies. We see benefits sometimes. There's one study actually where we saw it even after 3 weeks. I don't report the data here, but we don't know what is sufficient. Now, why is that important? It's important because people want to get a quick fix in many ways. They want to know that they're getting better. And so it would be ideal if we could see some performance improvements with relatively short time. The one thing that we don't know is, and this last study from Diaz Garcia, 2024, showed that if you stop the formal training, so when we stopped after 8 weeks and then we retested at 12 weeks with 4 weeks of no formal training, there's a drop off in performance. So what we need to be mindful of is if they stop the training, we're going to lose some of the benefits. So it looks like you need to sort of keep topping up, both for physical benefits and also for cognitive benefits. In terms of mechanisms, there's the effort recalibration possibility, brain adaptations that we have hinted at with the Dalloway work. But then when we think more broadly, what we would really like to do, particularly following up from this study with these older Spanish ladies, is to see whether these benefits that we see in our formal tests, things like the 6 minute walk and the chair stand and the bicep curls, whether the benefits of BET go beyond the lab and into activities of daily living. And then even more broader than that, whether then the benefits of BET actually have improvements in health more generally. And so in terms of the applications, the last point here, obviously these are exciting findings. We're very happy with them. We want to build on them and test and see what the real possibilities are with BET. We have an aging society. I myself am getting on a bit, and I'm fully aware of the declines in my physical and cognitive performance. And so these sorts of activities and these sorts of trainings should be made more widely available, and people can evaluate them. And then in terms of the more basic work with BET, I think the professional athletes can benefit from this, but also I know that other service personnel, firefighters, etc., they could also presumably benefit. In any situation where mental fatigue is a problem, and to be honest, it's a fairly ubiquitous finding or phenomenon, I think that, and particularly where there's like a combination of physical and cognitive demands, which is most jobs and activities that we have to do, to be blunt, then I think that there's a role to be played by this sort of training, integrating combined training to benefit all. And that, as they say, is that. Thank you very much for joining us, and I'm happy to open up the floor and answer people's questions. Over to you, Cecilia or Bob.
Yeah, thank you so much, Christopher. So, yeah, we have here with us Professor Christopher Ring, and I would like to inform the audience that we are opening the floor for questions. So please feel free to raise your hand and ask a question if yeah, you want to ask Christopher some question. So we have here Frank and Ayo and also Kyle on stage. And yeah, I don't know if Bob has a question. Just let me know, Bob, if you have a question here uh, for Christopher. So yeah, initially I'd like to just ask maybe one or two questions just out of curiosity. So, are you there now in Waseda Daigaku to have a study based on, you know, for the use case of the aging population?
What is the question? Why am I here in Waseda University at the moment?
Yeah, because I was suspecting, of course, Japan is always interested to have some studies regarding the aging population. So, in relation to BET.
Yes, I mean, I'm here hosted by Professor Hiroaki Masaki at Waseda University, and Professor Masaki, his expertise is in use of EEG electroencephalography and fMRI. They have a scanner and a number of setups for EEG. So we're discussing the possibility of looking at the mechanistic work, looking at EEG and fMRI in both athletes, but also more generally in the older population. As you say, Japan has in some ways, it's something to be jealous of. They have a very large aging or aged population, but associated with that, there are some issues around. So we definitely are going to look to see if we can get some funding and maybe just do some pilot studies to look at the benefits of BET in the population here in Japan.
Yeah, thank you, Christopher. Just one more question. You said that basically the duration of the study that you have would be around 6 to 8 weeks.
Yes, I mean we don't really know what's I mean when you I mean the problem is these studies are difficult. If you start adding up the number of sessions over the number of weeks, it's typically 3 sessions, 4 sessions, 5 sessions a week, and when you're doing even just 4 4 weeks of training, you're already up to close to, quite large numbers. And if you carry on for, 8 weeks or more, you're looking at substantial numbers. We don't know what is required. We don't know what the necessary number of sessions or duration of sessions or difficulty of sessions is. I suspect it will vary depending upon the level of experience of the people. So, for example, the studies we've done in the professional athletes, the number of sessions has been relatively low, and one of the reasons for that is because there's less variability in their performance, so it's easier to detect changes. Once you start going to non-athletes, people who are not expert at doing particular tasks, which is, to be honest, the rest of us, 99% of the population, then I think that we need to do the training. And the way I see this is, it's just if we can get people to engage in exercise training or cognitive training, that's great. And if they're doing that already, that's great. And all that I would like to see and encourage people to do is, if they're doing some cognitive type of training, cognitive activities, to do that and integrate it with exercise. Or if they're doing a bit of exercise, to integrate it with some cognitive activities too, and to see and reflect on whether they're getting, added benefits. The trouble with sort of one-off studies is that they are just that, and what you want to do is change people's habits for life. You want to change how they engage in their so-called social non-work time, and or even if and then into retirement, that their people are still active, and you want them to be active cognitively and physically. So that's how I see it. How we get people to engage at that is through promoting, the benefits of this sort of training.
Yeah, I'm very curious if um, you have experienced or have tried trying to train someone who is simultaneously doing a cognitive and also a physical exercise
Yeah,
at the same
in
time.
fact, yeah, that's a very good question. In the early days, the brain endurance training protocols were what we would call concurrent training. So while somebody was, let's say, exercising on the bike, or while someone was doing the hand grip tasks, we got them to do cognitive tasks at the same time. And when you have that type of training, it's much more difficult, and it's a dual task paradigm. And when you have a dual task paradigm, what happens is one or both of the tasks, the cognitive task and or the exercise task, you don't do as well at them, because it's the task require certain amount of cognitive resource, and there's only a limited amount of cognitive resource. So if I ask you to pedal, while I'm also asking you to do something like a stroop or a memory task or a switching task, you can't do both really well. And so so what it tends to happen is that performance, you tend to, for example, on a bike, you tend to slow down a bit. On the cognitive thing, you tend to respond a little bit slower. So what we've moved away from now, we don't use that particular type of training protocol anymore. What we tend to do is we tend to give the cognitive task before they start to exercise. And then if they're doing some form of intermittent exercise, let's say they were doing some work in the gym, we would interleave the cognitive task, brief cognitive task, with the exercise sets. So they'll do a set of exercise, or they'll do a bit on the bike, and then they'll do some cognitive, and then they'll go back to doing another set of exercise or a bout of exercise. So that's something that we call intermixed bet. So and the great advantage of that is that people are normally, when they're doing their physical training, they build in little rests. And so what we do is we kind of preload them before they start, maybe give them, 10 or 15 minutes of cognitive at the start. And then every sort of 5 minutes or so, we give them maybe another 3 minutes of cognitive. So it's this interleaving of the two types of demands, physical demands and exercise demands, so that it you don't tend to get this issue with dual task drop off and underperformance.
Yeah, thank you so much. So I'd like to give the mic to the speakers here on stage, and we'll go in PTR order. Bob, do you like to ask a question? Uh, yeah, if not, yeah.
No, no, I'm all set. I'll defer.
Yeah, all right. So we have Frank, Eric, and Dude, and Kevin. So, Frank?
Yeah, can you hear me?
Yes.
Yes, clearly.
Sounds
Okay.
good.
Yeah, so cool. Yeah, thanks, Dr. Ring. And this is very timely research, and I think it's very very. I mean, probably the most important. It's the most important organ is human brain. So I just happened to attend a memory contest at just happened in Boston over last weekend, and there's this game that they design. It's, I mean, this is different faculty part of the brain. It's memory kind of a part, and the game is called the Lumosity. I don't know if you have heard.
Yes.
I mean, yeah, okay, cool. So it's amazing that people. It's like Olympic train different muscle, right? This is brain muscle, and the champion this year can remember like 68 cards out of 152. So it's amazing. It's just like a Guinness record or something. So my question to, I mean, I have a dozen questions, but I think your, I mean, there, as you mentioned, explained already, this scientific research experimental is really hard to do, expensive in repetition and also sample size wise. So, you mentioned there is a part. You mentioned the cognitive resource of the brain. One thing, one question. I mean, is there a particular seat? Is that an intention like center, like hippocampus, or is there a so when you mentioned that the cognitive versus physical, I would guess that they are competing for the same spot, right? Resources, and I guess in the future, functional MRI, you would regarding the Stroop phenomena effects, are these pathways already been? What's the status? It has been. Is the consensus already among the researchers, or is still there's contentions or still work in progress?
Yeah. So I mean, we are aware, and we read the papers looking at studies that look at the changes in brain activation patterns during classic cognitive tasks, classic, inhibition or memory updating or task switching executive functions. And there's also a smaller literature, because it's much harder to do, looking at brain activation patterns during exercise. Obviously, in the scanner, there are limitations to doing that, but people still ingeniously sometimes manage to do it. And generally speaking, I'm not a sort of a neuroscientist, but generally speaking, there seems to be overlap, as you suggested, in the sorts of more prefrontal regions that are involved in both exercise regulation and in cognitive task performance. So the framework that's driving our thinking is that there is a limited resource, and that if you have tasks that physical, or if you have two tasks, a physical task and a cognitive task, and you're doing it for long enough at high enough intensity or difficulty, you start to overwhelm that resource. And that is it's like a training stimulus. It's a cognitive training stimulus. It's a physical training stimulus. And that has to create some sort of adaptation. I personally don't think that we're increasing cognitive capacity per se. I happen to think that we're probably increasing cognitive efficiency. People work out a better way of doing, let's say, the cognitive task. The recalibration of the effort for physical exercise is something that was very appealing for the early task when we are looking at exercise endurance. What I didn't mention is that we've also seen benefits with more skill-based exercise tasks. I mentioned that Dr. Diaz Garcia, he's a paddle coach. So we've done quite some studies on paddle tennis. And we find that brain endurance training improves tennis serving or return of serve skills in tennis, which is clearly a skill. Now, is that because we're improving their endurance because they hit a number of balls back during those tasks? Or is it that they're better able to perceive the ball coming over, plan where they're going to hit it, when they're going to hit it? We don't really know, but the original explanation that it's all about endurance exercise doesn't seem to hold. So we're having to rethink our model to extend beyond not just endurance exercise, but to other aspects of physical performance. So, in sum, I think there is overlap in terms of brain areas, but those studies have not been done, and they definitely need to be done because people like to understand mechanism. From a purely practical point of view, I'm not really sure that it matters for most people. But from a sort of an academic point of view, it would be nice to learn about mechanism. The idea that you mentioned at the very beginning with these apps that are now available. I mean, we happen to use the Soma app. We started using it because lockdown came and the labs were closed and we needed to train remotely and do testing remotely. So that's how that was one of the sort of beams of light coming out of the pandemic closure. We realized that it's possible to do testing anywhere in the world, and do studies from anywhere in the world. But there are a whole slew of different programs available on the App Store or on the Google Store, and you can take cognitive tasks and use them. They tend not to be so well worked out, but there's plenty of cognitive tasks to do there, to push yourself before and during or between exercise.
Well, great. Yeah, that's a lot of info to digest. Just a quick follow up from what you just shared, and I guess a technical question, more technical question. Are you alluding to the? So basically, I was led to the question that in your BET, brain endurance training test, that for example, the Stroop game or Stroop test are there critiques on whether they are, like, if you are doing it more times, you're getting familiar, and the games will become easier the more experienced you are. Would that a little bit the counter against the purpose of the test of the?
Yes, that's a very good question. Like all humans, our participants get better at doing tasks. We learn how to do things. That's what being human is. And so, because this study was done in Spain, the old lady study, we didn't have, and the app that we use is only available on the iPhone, the iPhone iPad platform. We had to get some other tasks. And those tasks, that's why we were limited with just doing the PVTB and the Stroop. Now, what we do now in our studies, and this is what we are planning to do moving forward for all of the studies, is when we ask people to do the cognitive training, we like physical training where you have this principle of progressive overload. So every week or every few sessions, the training stimulus becomes higher, becomes harder. So if you're having to lift weights, you don't lift the same weight every time for 8 weeks. You add to the weight to increase the stimulus. You might not just, for example, do one form of exercise for training, but you'll do a variety of trainings, because again, people adapt and you have to change the training stimulus to allow for that adaptation. Exactly the same thing happens with cognitive tasks. So what we now do is we have a battery of tasks that we give people. We don't just give people one task, one cognitive task, because we know that people learn how to do that task, and it becomes less of a stimulus if you keep it the same. So we vary across different tasks. So we have inhibition tasks, we have memory updating tasks, we have task switching tasks. And what we do as well is nearly always now we run these tasks in so-called adaptive mode. And what that means is that the software is able to track how people are doing, and then it monitors their performance over a block of, say, 10 trials. And then if they've done well in that block, it makes the next block of trials harder. If they haven't done so well, it makes the next block of trials easier. And so what that does is it adapts and titrates task difficulty as people learn or people disengage a little bit. So that's for me, those are the important features. You have progressive overload for cognitive, and you have novelty. So you have different tasks, you switch them around. You essentially you try and make training interesting, because if training becomes boring and repetitive, you're less likely to get compliance and engagement with the training protocol. So it's, the principles are really very simple. People understand them for doing gym workouts and creating training programs for athletes. It's the same thing for the cognitive training. You have to push people and you have to challenge people and you have to realize they're getting better along the way. And that's what we now do with our latest study protocol.
Well,
Thank you.
that's really great. And this is like the
Frank, can we
renormalization.
just go back to you?
Oh,
You know,
let me
but
finish.
there
Let
are
me finish very quick. I have no more question. I just like a comment to finish the round. Okay. So this is like a renormalization of the stimuli. That's great, and I definitely recommend the BET to colleagues and interest friends, and really look forward to more like exciting results. Even like from the cross discipline with neuroscience and maybe even AI, wearable like electronics measurements. Yeah, a really exciting future. Yeah, thanks, Chris.
Yeah, thank you very much.
Yeah, thank you, Frank. And yeah, we have Eric here, Kyle, and Kevin. So thank you for patiently waiting. I'd like to pass the mic to Ayo.
Yeah, so thanks. Yeah.
Eric?
I don't hear him.
Sorry, hello?
Eric, you're
Yeah,
next.
Yeah, hi. Thank you for the talk. Really interesting. My question was, I guess, if there's been any work. So the work that I did before was in multisensory integration in a neuroscience lab, and we looked at like VR scenarios of like recalibrating old people's balance and proprioception and things like that. So obviously we've seen the ability to cause the drift. So to help people to recalibrate. Have you looked into, I guess, gamifying this or making this more accessible? Because that's one thing that our lab was looking at before. And the last, or the second question for now would be, in terms of professional settings. So we see a lot of people, I guess, maybe more children nowadays because of social isolation, experience these kind of anxieties. And so, are there situations or scenarios that you imagine that would be like professional settings where, hey, adding some cognitive load, like, hey, look, there's a bouncing monkey that you think is on your shoulder, because we can do that kind of thing in VR. We can actually cause these sorts of very isolated, very focused kind of tests of this sort. So there it is. Thank you.
No, thanks for the question. In terms of gamification, we have actually stayed away from that side. With the CEO and developer of the app that we use, Soma, he has had some experience in the past with apps that have been using gamification, and he's not keen on it. So we've tended to stay away from that. Rather than take that approach to try and increase task engagement, we've gone down this other approach of trying to make. There's lots of different tasks. They're standard neuropsych or cognitive tasks, and we have a large battery of them, and we run them in Soma. We run them in different modes. I mentioned one of the modes already to you, this adaptive mode. So you can run just the bog standard task that just stays as it is for 5 or 10 minutes or whatever. But you could also run it in this adaptive mode, so it adapts to people's performance. We have other things we're able to do as well with Soma. So you can give people feedback on performance. You can give people exercise. You can integrate exercise requirements to make a response. There's a whole sort of
I guess my question was more about immersion, though, because it's not clear to me what the medium is, and so that was kind of, I guess, the
yeah.
direction of the question.
Yeah, I mean, my understanding of VR is very limited, and I, I do understand that VR can create new tasks. I just don't know how easy it is within the VR environment to create tasks that adapt.
Yeah, it's technically difficult. So, like, the lab had to hire a technical support, but most students nowadays, especially with kind of the technologies of the AI as we see, natural STEM students can actually pick up some of the game technologies and build up very quick prototypes for unique situations. So, the whole point for us was prototyping acceleration, and you mentioned also like the difficulty in getting participants, because like with us it was about the amount of folks you could actually get into the lab at the time, and that's why we were looking at potentially just releasing a game, because then we can get much more data. Maybe it's not as high fidelity. Maybe people don't have EEG devices at home, but we can actually see a statistical difference, kind of like Lumosity does. You may see that kind of. So that's kind of the question, because I see this work being very invaluable, and Japan's a great place for this kind of work to take place, but it would definitely benefit from becoming more widespread. So, if you have any plans in the future to do anything professional,
Well, I mean, here actually at Professor Masaki's lab, one of his PhD students has actually, who's just started about a year ago, he's come from a background of VR. And so we're in discussions about the potential for using VR training. The only issue that I have with VR, well, I have a number of issues with VR, mainly out of ignorance, I must say, is that the stimulus is a compound stimulus. It's not quite clear what the demands are when you create these tasks.
but
Is
you can
it
isolate them though, so you can make the environment dark. It can only be acoustic, for example. So it's like it's super tailored. You can control a lot of the parameters, and we even used. noise canceling headphones. We had two pairs of them with an insulated set, so you couldn't even hear anything. And there was a moving platform, so we could mess with your sense of balance. So all of a sudden, you're moving to the diagonal to the right, but the platform's actually moving to the left. But to you, it looks like it's moving to the right, or you
Mm.
feel like you're moving with the platform to the right. So those kinds of scenarios were actually really um, helpful for some of the folks. And so I guess just in terms of designing the next protocols, like I remember the thing like when we grew up, it was like, hey, rub your tummy and do something on your head. Kind of that's what your study made me think of. I was like, oh yes, that's that kind of like, can you multitask? And if you can multitask, then you can extend it out. So for me, for example, I also think of something like mathematics that, when studying mathematics, maybe some people do well with music, others don't. And so, yeah, my last question is, were there any indicators that allowed you to separate how participants performed? For us, there was some difference between male and female participants, but nothing quite significant. They still grouped together. And you mentioned that you studied mostly females. So, were there any findings, or was it just that the male participants were less willing?
Well, in fact, this last study was entirely women, older ladies, and which is unusual because most, I would say 95% of studies in exercise physiology are in men, because women are deemed to be a little bit, I don't know what, but they tend not to. We didn't do that. We tend to, in our other studies, to recruit both men and women, and we don't tend to find any differences in the effectiveness of BET on their performance. We haven't really looked at other individual difference factors, but undoubtedly they're there to be discovered. I think this idea of there being an interaction between, let's say, personality characteristics or some cognitive characteristics and the training stimulus, i.e., exercise and cognitive loading, is something to be discovered. And I
Yeah,
think the point that you raise about sort of tailoring the task or tailoring the requirements, I think is a fascinating one. I do think that multitasking is the way forward. I don't have expertise in VR, so I would be very happy to collaborate with people who have
yeah,
that
yeah. I would,
expertise.
I would love to connect you with the lab.
Yeah.
He's one of the co-founders with our company, and it's Professor Dr. Michael Barnett Cohen out of University of Waterloo here in Canada. So just so you know the reference. But I'll make sure to contact you after the talk. Yeah, I'll let others ask questions, and I have a few more, but I'll leave that for now. Thank you, Cecile.
All right. Yeah. Thank you.
Uh, Thank you, Eric, and thank you, Christopher. So, Bob, do you see in your PTR order who is next? I
I
just want to.
I have Nas is next, and then I have Kyle and Kevin on deck.
Okay, thank you. So, will you take over the moderation to bring the speakers in PTR order?
Sure thing. I'd like to welcome Nas to the stage. Are you there?
Yeah, I am. Thank you very much. Thank you, Professor Ring. Two questions. The mental fatigue. Are there any correlation between mental fatigue and Alzheimer, or most recently, the so-called COVID brain fog? It seems there are lots of similarities, but I would like your input.
Yes, I mean, I'm not that familiar with that literature. I am aware that there are a number of patient groups, including, you know, Alzheimer's and including post-COVID patients, who seem to be reporting elevated symptoms of mental fatigue. Whether that's the same as the sort of mental fatigue that I have more experience in, I really don't know. I think that there's people trying to look at that and trying to distinguish between different classes of mental fatigue, or is it that the construct of mental fatigue is the same, it's just slightly different manifestations? It's a fascinating question, but it's a little bit beyond my understanding, to be honest.
Okay. The second quick question: are there any diagnostic tools that you could use to in a laboratory to measure the mental fatigue, because if we are looking for some sort of treatment or therapeutic, we probably would need somehow some diagnostic tools. To your knowledge, are there any diagnostic tools for mental fatigue?
No, there aren't. I mean, when people try and assess mental fatigue, the the best way of going about it is by you ask for some self-report data, some subjective ratings. Um, People also will use cognitive probe tasks to look at changes in accuracy and reaction time to a few standard tasks, and then there's a growing literature on looking at physiological, neurophysiological correlates of mental fatigue, things like heart rate variability. There's work looking at sort of blink rates. There's some work looking at EEG changes. But in terms of a formalized, established, validated diagnostic test, I'm not aware of anything.
Thank you very much.
All right, thank you, Nas. Kyle, are you there? Hello, Kyle. All
Yes,
right.
I'm here. I just need 2 minutes.
Okay, we'll get back to you in just a second. Kevin, have you got a 2-minute question?
Oh yeah, actually, yeah, just too many. Yeah, for 2-minute question. Yeah, maybe I missed some of this, so perhaps the most important one I can think of. Hopefully, you didn't answer it. And I thought we had a room similar to this, but uh, the potential interactions between the exercise, genetics, and cognition is one thing I can think of.
Yeah, I mean, I'm not aware of anything that has looked at that, but I'm sure it's something for the future to try and understand in terms of vulnerabilities. It gets back to this issue of sort of individual differences and moderators. I'm sure that there's some clever geneticists out there who would be able to answer that question much better. But
Yeah,
it
next
wouldn't.
time for your next study, just make sure you have participants spit in a test tube. That's what we did, and we were able to just pick up their genome, and they found a pairwise set of genes that confounded for nausea in VR. And it's interesting because up until then, everyone said, no, 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 it's just you. It's your problem. It's psychological, you see. And so they found this kind of interesting connection. So it would be very fascinating to see. Also, immediately comes to mind is Formula One drivers. That would definitely be something where there would be a lot of research money there, because the endurance those drivers have to basically endure is quite unexpected. People don't realize like they have to be able to withstand 6 Gs on a turn or something. So that's a lot of power in your neck. And so these drivers spend a lot of time training for those endurance 90-minute sessions. And so this would be fascinating and probably really well translating work.
Yes,
Air
it's funny
Force
you should.
pilots would be another category.
Hmm. It's funny.
Yeah, something about civilian though, right?
In terms of the F1 question, we're in negotiations now to try and help out a team with their driver training program, because, as you say, these are some very, very special individuals who have massive physical load and cognitive load during very demanding conditions.
Yeah, it's like
And
the best athletes in the world unexpectedly.
yes,
Like,
yeah, absolutely, no, yeah, it's true, and the problem is getting into that environment is that they don't have much time these days. To be perfectly frank, we've been trying to set something up for over a year, and the calendar is now so full, and it's getting fuller. I think we're up to 25 races a year now. That there's not much time to go in and do some things. But I think that this sort of training, I mean, they're doing a lot of other training already. As you mentioned, they pull lots of Gs, and so they need to have lots of very good exercises. They need to be, they need to be elite endurance and resistance, and athletes, as well as being super cognitive abilities. So we are trying to get there, and I do think that we have something to say to help these people, but it hasn't quite taken off the ground yet.
Yeah, it just makes me think of, hey, driving with a rowdy a navigator, is that really good training for driving through that course yourself later? So it might be something there, definitely.
Yeah,
Kyle, if you're back, just want to make sure Kyle's back if he's available.
Yeah, I just want to ask Christian, which Formula drivers are you talking about? Is it in UK or
Yeah, I want to
there's
know
some,
that too. I'm gonna make a bet.
sorry, but I'm not allowed to say that.
no? I'm just asking because I might be able to connect you. So are you
Oh,
familiar?
okay. Well, yeah, as I said,
And
we
someone in the family who is doing that. So that's
yeah.
why I'm asking.
No, I mean, I know from speaking to Grant, who's the CEO of Soma. He has drivers across different sort of driving disciplines working with him. I don't think I'm not sure if he currently has an F1 driver, but he has in a number of different sports, and they these are sort of case studies. He does individual training with some of these athletes, and they find the benefits in when they're racing under these rather demanding conditions. But yeah, we're always interested to talk with to these particularly these extremely sort of demanding sports. F1 or any form of motor racing, I think, is an extremely demanding sport. So yeah, I'm very happy to chat with people and see if we can help them.
Yeah, thank you.
oh, I was just gonna
So
say. Oh, sorry.
yeah, Kevin, just a minute, please. We've been here for 1 hour and 35 minutes, and we have Kevin and Esan and Kyle who hasn't spoken yet. I wonder, Christopher, how much more time do you have for us?
I'm open. I'm happy to chat for as long as you want.
So let's now go to Kevin.
I was just gonna make a comment. Yeah, it looks like besides going on with more questions like neuroplasticity and stuff, but I got a friend who's executive at a company for F1, and my name's on lots of racing games from Atari. So I guess I'll see if I can do anything with any of this and contact you. But thanks.
Yeah, thank you for reaching out. I look forward to chatting.
Thank you. So I wonder if Kyle is able to speak now.
Yep, yep. So I just got the neuroplasticity was something that came to mind right away. But I was also wondering about ATP. Did you look into ATP or neuroplasticity by any chance?
We haven't done that. As I said, there's only so many things you could do with these first studies. They're demanding, but we would like to do those sorts of issues. We would like to do, take sort of blood measures to look at markers, to kind of corroborate the behavioural changes we're seeing with cognition. And in terms of the neuroplasticity, again, we would, one of the reasons for me coming out here to Japan to chat with Professor Masaki is to start to look at doing some EEG studies in particular, in terms of you know exactly how to assess neuroplasticity. I'm open to ears in terms of recommendations of the tasks and the methods you would use. I mean, and it would be very relatively easy. I mean, at the moment, what we tend to do for these studies, we do one pre-test session and one post-test session, sometimes a little bit more. But to be honest, I could think of probably multiple pre-test sessions and multiple post-test sessions to look at a whole variety of different things. It's just a question of whether our participants would tolerate that on top of all the other trainings and things we do to them.
No, that's amazing. Thank you. Yeah, no, I was thinking maybe perhaps an increase in neuroplasticity or an increase of efficacy for burning ATP as it's required for thought. I was also thinking about perhaps that Now, a lot of people, there was a comment about attention in the back channel just recently, and a lot of people think that mindfulness practice and meditation is just relaxation based. But there are other forms of meditation that are arousal based. And I'm wondering, and generally they're like, it's because of the parasympathetic and the autonomic nervous system. The relaxation type, it will kind of relax the response, and an actual arousal based meditation will actually calm the sympathetic nervous system. Um, or actually it will, sorry, which stimulates the vagus nerve, is always the best way to elicit peak performance. Some high stakes challenges, such as being Top Gun and flying fighter jets, require SNS driven inner fire and bursts of laser focused attention, known as phasic alertness. So I'm just trying to use technical language for the sake of you. But basically, what I'm thinking is perhaps this training is actually strengthening the autonomic nervous system as well, and creating an increase of attention capacity in the individuals.
Yeah, I mean, in terms of the autonomic, we have in some studies looked and measured heart rate variability. Primarily, we look at one particular metric, SDNN, which is primarily a sort of a parasympathetic correlate, let's say. We have sometimes found effects for that, but often not find effects for that. So maybe it's time for me to go back and more carefully sort of probe that to see whether we're getting those changes. Uh, Generally speaking, we're not finding much in terms of changes in the cardio or the cardiac parameters, but we haven't we haven't really designed tasks specifically to look at that, to be perfectly honest. But I do think that it's a good thing to do, and I think we'll have to look at that.
Yeah, it'd be amazing. I was thinking about the increased ability of serving, just how important attention is in that whole process.
Yes.
And then I was also thinking about, and this is my last comment, flow state. The rigorous training that you put people through could perhaps be helping people achieve a state of flow, which therefore would increase their performance. And that's the last comment. I just have to say
Mm,
thank you. Um,
yeah.
it's incredible the work you do, and hopefully it will be used to help a lot of people strengthen.
Yeah. Thank you. I mean, in terms of the study that I mentioned about paddle tennis, where they were able to 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 return the ball better, more accurately. We did actually do a little probe where we sat people in front of a screen and tracked eye movements after the training as well. And what we were finding there was that the bet had some improvements in ability to track targets on a screen. And we made a rather bold and rather probably unsubstantiated, guesstimate what might be happening, and it might well be that overloading people with these cognitive tasks, they are changing. I'm not sure if they're changing capacity, but or if they're changing cognitive efficiency, but maybe they're able to pick up the ball earlier, and then maybe they're able to then make their return of serve more accurate after that. So I do agree that I mean attention is at the heart of nearly all of the things that we do. So it wouldn't be surprising that we're going to pick up some improvements in attention tasks. We just haven't really looked at that and focused particularly on attention, which is probably something that we should do more of. In terms of the flow state, that's a really, really interesting question, because just the other day we've started a resistance training protocol in the lab, our latest study. And what we're getting people to do is to do lifting to quite high quite high loads. And what we noticed was when we were giving people these, using this so-called intermix sort of bet stimulus, where you get somebody to do an exercise set and then they do a cognitive set and then they do an exercise set. And the latest thing we're doing, these are in young sort of athletes, so we're able to create really very difficult and very demanding cognitive tasks. And what we actually suspect might be happening, I mean, it's only just observational data at the moment with a few cases, but when we interviewed people after having done these really hard cognitive tasks and these really hard physical tasks, the things that they were describing were very similar to a flow state. They seemed there seemed to be this distortion of time, and there seemed to be some distortion in terms of awareness as to what was going on. Now, whether that's just some sort of massive distraction that's happening when we're now using very high cognitive load and very high physical load, I don't know. But maybe maybe this idea of the flow state extends to some of our earlier studies where people are having to do this multitasking. I really don't know, but it's an excellent question and something that we're pursuing at the moment in this ongoing study now, looking at various measures of flow and what have you.
Well, thank you
Yeah.
so much. And if you would be welcomed, I mean, Cecile should be asking this question, but I would be open for you to return with the results of that study.
Mm,
And thank you.
thank you, thank you.
Yeah, thank you, Kyle. So we have Esan and Ash here on stage. And I think Ash will be our last speaker earlier. I would just like to mention that I also experienced going into some kind of flow state. I was doing Tai Chi for maybe about 3 months every other day. And but did not do, resistance exercise or something which is physically hard. However, I was able to notice that I can run longer and faster and lift objects, lift heavy, while after doing this Tai Chi exercises regularly. So I think it's also important to, and also a curious question as to what's also happening with this kind of training, just like what Kyle said earlier, like meditation and also like Tai Chi, in terms of the physical performance, whether it tries to improve cognition as well as physical resistance. So that's just my own personal experience that I wanted to share. In the meantime, I'd like to pass the mic to Esan, and after that, Esan, are you able to speak?
Yes, sure. Thank you very much. Uh, sorry, I wasn't uh, able to join at the beginning. So my question you may have answered. Actually, I have two questions. So one is, I looked at this second slide in the cost-benefit model of task performance. There is motivation, intrinsic, extrinsic. And I was wondering, how did you quantify or how did you characterize that motivation? And that is my first question. So, should I wait and then ask the second question, or do you prefer I ask both of them?
No, I can answer that one. I mean, that's a model that I sort of borrowed from. I sort of built upon what Sam had done, and that's more sort of to do with speculations as to what's happening when people are engaging in a task, and obviously one of the key determinants. I mean, this builds upon Brem's motivation intensity theory, and the idea is that motivation is essential to any ongoing task. You have to make a decision. Is the ongoing motivation, i.e., the effort, worth pursuing and worth continuing with when you have when you have a certain set maximum tolerable motivation. You don't want to go beyond. So it's really just a framework. We haven't closely measured intrinsic and extrinsic motivation per se, but it's something that's there in the model that we plan to look at in future.
Uh, Thank you very much. And so actually that is very interesting because I think that is both subjective and also uh, like is even within a subject it can change depending on some factors. So my second question was about your recent comment about eye gaze. So in my lab, I'm also doing eye gaze and basically eye gaze research and try to find and reason about the cognitive workload and also expertise level, particularly for medical tasks like surgery and things like that. So my second question is, uh, what are your thoughts of about basically looking into this uh, uh, brain endurance training, but control it for the expertise level? So basically, uh, like if we consider a spectrum from novice to expert for any part, even in in the for athletes, I'm doing it for surgeons, from medical students to an attending surgeon, but let's say athletes or any profession, what do you think this endurance model and training would uh, help with if we try to control for the expertise level? Like, for example, if we look at novice versus expert and try to see uh, how this endurance, do you think, like, for example, it is more effective for one side of the spectrum versus the other, or do you think it benefits all at the same rate? So that was my second question. Thank you.
Thank you for the question. It's an excellent question, and there is a little bit of research in the mental fatigue literature suggesting that the deleterious effects of mental fatigue are not as obvious in experts compared to novices, so their performance doesn't drop as much. As far as I'm aware, there's only actually one formal study that's compared. They were comparing professional cyclists with recreational cyclists, and showed that the effects of a mental fatigue manipulation, a demanding cognitive task, really didn't show much in the experts. Now, as I said, that's a one-off. So I'm a little bit puzzled why that's never been replicated or extended. But it's a fact that if you're a top level athlete or a top level surgeon, you've kind of been selected for these sorts of demands already, I would imagine. So you've probably along the way as athletes acquire some sort of resilience against the sorts of demands that they face. I would imagine that surgeons, and going from like a trainee surgeon to a very experienced surgeon, they've developed a whole set of skills that are able to sort of inoculate them against various demands, including the sorts of cognitive load that surgeons would face. I mean, it's a really fascinating question. It's one of those areas where we would love to go into, looking at expertise outside of sport, and I think that surgeons and training of surgeons is one of those areas. My own speculation is that the junior surgeons would benefit more from BET than the expert surgeons, just because I think that the expert surgeons have already developed a little bit more resilience, whereas the trainee surgeons, they need to become more resilient, more able to cope with all sorts of demands, including those that can create mental fatigue. And in terms of what we know about expertise, when you become more expert, like you manage to become more autonomous or automatic in a number of behaviors, including the actual, you know, physical skill of doing the surgical procedure. So I can imagine that you free up the resource there. So the mentally demanding cognitive activities or tasks, they they come they come upon an individual who's more expert, like who has more resource available, because they don't need to consume so much of their attention and memory and what have you while they're doing the surgery, compared to somebody earlier on in their career. But it's a really great question, and it's somewhere where I would love to explore in future.
Thank you very much. Yeah, I can email you, and we can. I am also very. I would be very interested to like collaborate on these thoughts. I also speculate similar that it is more effective for more novice side of the spectrum, as you mentioned, and for the same reason that they have already developed that endurance during their training. So, but I think it is a fascinating thing to explore, and to basically show it. So I would be happy to connect offline. Thank you again.
Yeah, it sounds wonderful. I mean, yeah, I mean, we know that if the experts are more resilient than the novices, maybe we can still help the novices to get more resilient faster. That would be the benefit, of course. I mean, they have lots of demands, but if you can accelerate that and make them more robust, then I think that would be fantastic.
Thank you, Esan. And yeah, we now go to Ash, who will be asking the last question.
Hi, Christopher. Thank you for the presentation. So great. I was wondering, I often had workout routines. For example, when you first do a workout routine, it's hard, but then your muscles get used to the motion. And I think, is that a similarity in terms of the BET and what happens when you're doing both of these activations, I guess?
Um, to be honest, we haven't really looked very much at the kinematics of movement. I mean, these days with sort of the pedals that measure power on the bike, and with devices that measure sort of lifting kinematics and velocity, what have you, we should be able to characterize those improvements, if they are there, with muscle or motor kinematics. The only thing we've looked at is looked at patterns of EMG muscle activation, and we have tended not to find much there. But in my own experience, the measurement of EMGs is a rather messy and noisy business. But I think that the tech that's available now to be able to monitor movement should give us some insights. And we've in our weightlifting weight training studies, we now start to look at the kinematics using particularly looking at the velocity profiles during lifting, and able to look at changes in velocity, changes in pacing. But we haven't had much success up until this point for just basic EMG. It just seems to be not differentiating people who do one sort of training or the other. But I find it hard to believe that if you're getting better at doing these tasks, you're not becoming more efficient or better at coordinating, or things like that. So it's something that we are actively exploring, and hopefully we'll find something there.
Yeah, and my hypothesis is that your brain gets more efficient at the task, and so it stops becoming an exercise for your brain and becomes more an exercise for your muscle. So I mean, I meant like measuring brain waves, not muscle EMG.
Oh, I see. Yeah, no, it's something we should. I mean, in another part of my research, we do look at well, focused mainly on alpha oscillations and looked at alpha gating as a function of learning various motor tasks. So it wouldn't surprise me that we'll get, more refined alpha gating, alpha oscillation gating, putting resource away from non-essential occipital, temporal, parietal regions and into motor areas. So we can definitely do that, and I have done that in a different context before. But I think that it would be interesting to do that for sure, particularly for certain types of exercise where you can actually do EEG measures fairly easily without too much movement. Weightlifting is a particularly good one, or hand grip contractions are particularly good because there's not too much movement to deal with.
And to extend that to flow, because I'm a little bit of a flow junkie and I also trained in flow officially, but does that also kind of extend to flow? Because, as you get more efficient at the task in flow, you're also, um, it's, it's getting easier. And so you need a higher level of challenge to get into that same level of state. And
Yeah, I
so
don't know
is
if
that
it's. I
kind of an
don't know if
extension?
that's. I don't know if it's flow per se, but it's definitely automatized performance as we become better at these tasks. So I can very well imagine we become we move towards automatization and we move towards efficiency. Whether that is what we're picking up, if that overlaps with flow, then so be it. I'm not
Sounds
quite
like the
sure.
hippocampus just sounds like the hippocampus just recognizes it and says, "Oh, I've seen this before. Here, let's stop burning all that fuel on that." So that's my suspicion.
Mm.
Muscle
Yeah,
memory.
yeah.
Yes. So, yeah, all right. So we're reached the top of the hour, and at this point, I think it's lunchtime. Yeah, for Christopher too. So I would like to thank you so much, Christopher, for being our guest speaker here, and thank you for answering all kinds of questions. We learned so much from you today, and yeah, we hope that we can invite you back again in Quantum Photonics sometime soon. So, do you have some parting words before we close the room?
Well, I'd just like to thank you and your friends in the club for inviting me. I had a great time. I really enjoyed chatting. I enjoyed hearing about other people's insights, and I'm always looking for collaborations. I'm always looking to be challenged, and so I hope that people feel free to get in touch. If anybody ever wants to try this themselves, I'm happy to set them up with an account, and they can have a play themselves. I think the most important thing is we get the message out there that I think this sort of multitasking, integrated form of training is what humans are all about. We shouldn't be just sort of doing one or the other. We should be mixing things up and challenging ourselves, whatever we happen to be, wherever we happen to be doing, or trying to improve performance for either performance sake or just for health and fitness. But thank you very much.
Yeah, thank you, Christopher, and yeah, thank you to all the speakers here, Frank, Eric, Kyle, and Kevin and Ash. And yeah, I would like to tell everyone that we're going to have a newsroom tomorrow. So if you want to share some news with us, please yeah, attend the newsroom, or you can just listen and yeah, discuss as well. Thank you, and I'd like to give thank you everyone on the listening lounge, and also V for being there and her comments on the room chat. So I'd like to give the mic to Bob if he has something to say, and otherwise, let's just do the count.